This conference will now be recorded.
I welcome you all for the session 1 of Fundamentals of Nanoscience. Myself, Balaji, Assistant Professor of EEE Department from IFET College of Engineering, Villupuram. In this session, we are going to discuss about nanoscience, nanomaterials, nanoscale and technology, and coming for amplification for physics, amplification for chemistry, amplification for biology, and finally amplification for engineering. These are all the contents we are going to discuss today in the session. Coming to nanoscience. Nanoscience is the study of structure and materials on the scale of nanometers. The term nano is expressed as 10⁻⁹ meter. Mass of solids can be measured in terms of nanograms, and amount of liquids can be measured in terms of nanoliters. Nanomaterials, or the newly developed materials, at the size of nanometer, ranging from 1 to 100 micrometer. Usually, as I said before, nanometer is expressed as 10⁻⁹ meter. The materials used to form these nanostructures generally have bulk properties, and its properties gets modified when when their sizes are reduced to nanometers. The main thing here is that the term nano is expressed as 10⁻⁹, and we call such material as nanomaterial when its size ranges from 1 to 100 micrometer. These are the two main points we should have with us. Okay. Nanomaterials, or the newly developed materials, at size of nanometer, range of 1 to 100 micrometer. This is the main thing, and this is known as nanomaterial. Coming to nanoscale technology, nanometer is 1 billionth of the meter. That is, we can say that it is 1/10⁹, and it can also be known as 10⁻⁹ meter. Okay. See, single strand of DNA is of about 2.5 nanometer wide. Thickness of a single human hair is about 50,000 nanometer to 100,000 nanometer. See this. Width of the red blood cell is approximately 7,000 nanometer. That is, it can be expressed as 7 micrometer. Water molecule is of about 0.3 nanometer across. See, from all above points, we come to know that nanoscience structures exist in nature before the scientists study and found them in laboratories. Most of the works by scientists and engineers are done in nanomaterials ranging from 1 nanometer to 100 nanometer. Nanostructures can be found and it can be formed in both solid and liquids. Nanostructures can be made by reacting chemicals in liquids and gases to generate nanofibers, nanocrystals, quantum dots, and some other forms of about 1 nanometer wide. Researchers were going on to build a 3-dimensional structures, and it is called as nano electromechanical systems. In short, it is denoted as NEMS. See, one day this nano electromechanical systems, that is NEMS, will be used as microscopic robots to carry out too small task for humans, like doing out surgery on a single cell. This nano electromechanical systems, that is NEMS, can also act as a mechanical actuators to move around the individual molecule. To magnify something 10 times, we can use magnifying glass. So to magnify something 200 times, microscope can be used, but to magnify in a nanoscale structure, high-powered microscopes should be used in an entire room. Okay, high-powered microscopes are needed. Scientists and engineers from various disciplines use nanoscience principles for advanced applications in energy, medicines, information storage, etc. Example, miniaturization of electronic devices to the sizes below 1 micrometer has revolutionized over our daily lives. Nanotechnology is a design, production, characterization, and application of structures, devices, and systems by controlling shape and size at the nanometer scale. In general, nanotechnology is the synthesis and application of ideas from science and engineering towards the understanding and production of novel materials and devices. See, I repeat once again for your easy understanding. See, nanoscience is the study of structures and materials on the scale of nanometers. The term nano can be expressed as 10 power minus 9 meter, and it can also be said as it has also been said as 1 billionth, that's 1 by 10 power 9, that is 10 power 1 by 10 power 9 or 10 power minus 9 meter. Okay. Mass of solids can be measured in terms of nanograms. Solids can be measured in terms of nanograms, and liquids can be measured in terms of nanoliters. Okay, nanomaterials are the newly developed materials, and it will be of range of 1 to 100 micrometer. Okay, these materials used to form these nanostructures, these nanomaterials will be used to form nanostructures, generally have bulk properties, and these properties gets modified when the size gets changed, or changed in sense reduced. Okay, see, single strand of DNA is of about 2.5 nanometer by thickness of a single human hair is of about 50,000 nanometer to 100,000 nanometer. Water molecule is of about 0.3 nanometer across. Width of the red blood cell is of about 7,000 nanometer, that is 7 micrometer. Okay. On seeing all those above points, we come to know that nanoscale structures exist in nature before the scientists study and found them in laboratories. Most of the works by scientists and engineers are done in nanomaterials ranging from 1 nanometer to 100 nanometer. Nanostructures can be formed in both solids and liquids. That is the main thing. Researchers were going on to build three-dimensional structures, and it is called as NEMS, that is nano electromechanical systems. See, one day this nano electromechanical systems will be used as microscopic robots to carry out too small task for humans, like doing out surgery on a single cell. This nanoelectromechanical systems can also act as an mechanical actuators to move around an individual molecule. See, nanostructures can be formed by reacting chemicals in liquids and gases to generate nanofibers, nanocrystals, quantum dots, and some other things which is of about 1 nanometer wide. Okay. To magnify something, we need magnifying glass. That is, if we need to magnify for 10 times, magnifying glass is needed. And to magnify something 200 times, microscope is needed. Okay, but to magnify in nanostructures, high-powered microscopes is needed. That it should be filled in an entire room. Okay. Uh, Scientists and engineers from various disciplines uses nanoscience principles for advanced applications in energy, medicines, information, storage, etc. For example, miniaturization of electronic devices to the sizes below 1 micrometer has revolutionized our daily lives. See, nanotechnology is the, if it is a definition, see, nanotechnology is the design, production, characterization, and application of structures, devices, and systems by controlling shape and size at nanometer scale. In general, nanotechnology is the synthesis and application of ideas from science and engineering towards the understanding and production of novel materials and devices. Hope you all understood about nanoscience, nanomaterials, nanoscale, science and technology. Now we are going to amplification for physics, chemistry, biology, and engineering. First, what is meant by amplification? Okay. See, nanotechnology is a multi-phased technology that covers various fields like science, um, engineering, medical science, etc. Okay. The use of nanoscience engineering for the benefit and development of various fields like science, engineering, etc. is known as amplification. Okay. I repeat once again, the use of nanoscience engineering for the benefit, or the use of nanoscale engineering for the benefit and development of various fields like engineering, medical sciences, general science, anything you can take is known as amplification. Okay. Nanoscience is the science of objects with typical size of 1 to 100 nanometers is one of the most important development in the last decades. Two new technologies which enabled the progress of nanoscience are scanning tunneling and scanning force microscopy. Okay, these are the two main technologies which is enabled in the progress of nanoscience. Okay, now coming to amplification for physics. See, mass of nanoscale materials is extremely small when the gravitational force becomes negligible. As the gravitational force becomes negligible, okay, mass of the nanoscale materials is extremely small as the gravitational force becomes negligible. See, the size of the particle gets reduced. The size of the particle or material gets reduced. Obviously, the weight of the material gets reduced. So it leads to the gravitational negligibilance of gravitational force. That's it. Okay. Wave particles duality of matters of objects have very small mass, has a pronounced effect. Similarly, nanoscale materials have wave behavior. See, now coming to quantum confinement, it is a change of electronic and optical properties when the materials are sampled into smaller size of about 10 nanometer or less. 2D quantum confinement leads to quantum wire, and 3D quantum confinement leads to quantum dots. These quantum wire and quantum dots will be discussed in forthcoming sessions. Okay, now have these words with you. Okay, 2D is to bring out quantum wires, and 3D confinement is to bring out quantum dots. Quantization of energy. Quantization of energy. Energy is quantized in some systems. Some system can have only certain energies and not a continuum of energies. Quantum dots are the nanomaterials that displays the effect of quantization of energy. Okay. Cooling chips or vapors can be replaced in place of chemicals. Chemical use as a coolant in compressors, in cars, refrigerators, air conditioners, etc. Photovoltaic, that is solar cell or fuel cell, are the power sources to provide inexpensive clean energy. Okay. Nanoparticles, reinforced polymer, that is a new class of materials consists of traditional polymers reinforced by adding nanoscale particles called nanocomposites. Adding even a small amount of nanoparticles leads to a drastic improvement of strength and stiffness of the polymer. This nanoparticle reinforced polymer gives out lightweight materials. Okay. Nanocomposite materials are used in vehicles for the fuel economy, and it is also used in non-automotive applications like pipes and other fittings in buildings. Also used in refrigerator liners, medicals, etc. Okay. See, lithium-ion battery will be replaced by nanotechnology power sources in future. Nanotechnology will help to bring out a new kind of power source like tiny photovoltaic panels, better batteries, miniature fuel cells, etc. Nanotechnology developments in thin film transistors bring out low power plastic displays in mobile computing, communication equipments, etc. Okay, this is amplification for physics. Let me repeat the thing. Uh, See, mass of the nanoscale materials is extremely small, which leads to negligibilance of gravitational force. Where particle duality of matter of objects have very small mass has a pronounced effect. Similarly, nanoscale materials have a wave behavior. A main amplification is quantum confinement. It is a change of electronic and optical properties when the material is sampled into smaller size of about 10 nanometers or less. 2D quantum confinement leads to quantum wire, and 3D quantum confinement leads to quantum dots. Quantization of energy, that is, energy is quantized in some systems. Some system can have only certain energies and not a continuum of energies. Quantum dots are the nanomaterials that display the effect of quantization of energy. Cooling chips can be replaced in place of chemicals in a coolant, which is used in compressors of cars, refrigerators, air conditioners, etc. Photovoltaic cells, fuel cells, or the power source to provide inexpensive clean energy. Okay. Nanoparticles, reinforced polymer, that is a new class of material consists of traditional polymer reinforced by adding nanoscale particles called the nanocomposites. Adding even a small amount of nanoparticles leads to drastic improvements of strength and stiffness of the polymer. This nanoparticles reinforced polymer gives out the lightweight materials. Nanocomposites materials are used in vehicles for the fuel economy, and it is also used in non-automotive applications like pipes and other fittings in buildings. Also used in refrigerator, liners, medical applications, etc. See, lithium-ion batteries will be replaced by nanotechnology power source in future. Nanotechnology will help to bring out a new kind of power sources like tiny photovoltaic panel, better batteries, miniature fuel cells, etc. Nanotechnology developments in thin film transistors brings out the low power plastic displays in mobile computing, communication equipments, etc. That's it about the amplification for physics. Now coming to amplification for chemistry, nanomaterials is formed by an by atom or by a cluster of molecules. Okay, cluster of molecules leads to atom. The cluster of atoms leads to a material or a compound, or what can we say, to any of material. Okay. They are generally classified as they're generally classified into two types. One is intramolecular bonding, one is intermolecular bonding. Now coming to intramolecular bonding, these bondings involves the change in chemical structure of the molecules. This bonding include ionic bonds, covalent bonds, and metallic bonds. The bonding process is by chemical interaction. And on the other hand, intermolecular bonding, this type of bonding does not involves the change in chemical structure of the molecules. They include ion-ion and ion dipole interactions. Here the bonding process is by physical interaction. Okay. See, in general, for the amplification for chemistry, nanoscience, nanoscale particles exhibit high equilibrium vapor pressure, chemical potentials, and solubility when compared to bulk materials. This is due to high surface energy of nanoparticles. Ionization potential increases as the metal atom clusters at normal scale gets reduced to the nanoscale. And nanofluidics, it is the study of the behavior, manipulation, and control of fluids that are confined to structure of nanometer dimensions. New cathode nanomaterial for the lithium battery are the target for novel nanostructures. Construction of nanostructures is by chemical vapor deposition of benzene on Cu111 in an ultra high vacuum chamber. See, sustainability. Nanotechnology will improve agricultural yields, economical water filtration, and desalination that enables the use of renewable energy. Okay, this implication of chemistry leads to the use of renewable energy in future. Okay, this is about amplification of chemistry. Let me repeat this thing once again. See, nanomaterial is formed by an atom or by cluster of materials. This is classified into two. One is intramolecular bonding and one is intermolecular bonding. And this bonding involves, intramolecular bonding involves in the change in chemical structures of the molecules, and they includes ionic bonds, covalent bonds, and the metallic bonds. And this bonding process is by chemical interaction. Coming to intermolecular bonding, this type of bonding does not involve in change of chemical structures of the molecule. They include ion-ion and ion dipole interactions, and here the bonding process is by physical interaction. Okay, see, nanoscale particles exhibit high equilibrium, vapor pressure, chemical potential, and solubility when compared to bulk materials. This is due to the high surface energy of nanoparticles. Ionization potential increases as the metal atom clusters at normal scale gets reduced to the nanoscale. New cathode nanomaterials for lithium battery are the target for novel nanostructures. Construction of nanostructure is by chemical vapor deposition of benzene on copper in an ultra high vacuum chamber. See, nanofluidics is the study of behavior, manipulation, and control of fluids that are confined to the structure of nanometer dimensions, that is 1 to 100 nanometer. And the sustainability is that nanotechnology will improve the agricultural yields, economical water filtrations, and desalination, and enables the use of renewable energy. Okay, now coming to the implication for biology. Okay, nanotechnology can provide new formulations of drugs, that is enormously broadening the drugs therapeutic potential. Advanced drug delivery systems automatically administering drugs and capable of censoring the drug level. Medical diagnostic tools, diagnostic devices for physicians. These are the implications for biology by nanotechnology. Okay, studies on cell biology and pathology to characterize the chemical and mechanical properties of the cell. Artificial, inorganic, and organic nanoscale materials are developed and introduced into the cells to play roles in diagnostics. See how nanomaterials or how nanomaterial is used for used in medical fields. Nano-engineered gels are used to replace the lost tissues or to provide structures for regeneration of natural tissues. See, detection of specific chemicals or biological compounds within a mixture represents the basis for the operation of numerous devices like chemical sensors and biosensors. Nanotechnology will contribute directly to the advancements in agriculture in a number of ways. That is, molecularly engineered biodegradable chemicals for nourishing plants and protecting against insects. And second one will be genetic improvements for animals and plants, and third one will be nano array based technology for DNA testing. These are all the contributions of nanotechnology in advancements in agricultural field. Okay, see, in biological fields, this nanomaterial is helpful in diagnosing the chemicals in a cell or chemicals, and it can also be used to characterize the chemical and mechanical properties of the cell. See, medical diagnostic tools and diagnostic devices which can diagnose even in a single cell can be brought out to this nanotechnology, which nanotechnology contributes to the medical sciences. This all comes under biology. Okay. Now, amplification for physics. Amplification for engineering. Nanoengineering is leading to better fuel cells and photovoltaics. Nano-engineered catalysts can be used to extract oil or turn oil into fuel for cars. Replacement of carbon black in tires by nanometer scale particles of inorganic clay and polymers. Significant changes in lighting technology are expected in next 10 years. See, nanoengineering replaces chemotherapy with an injection of specially prepared nanoparticles that kills cancer cells for the patients. You can ask me that this comes under medical sciences. Okay, biotechnology comes under engineering. Engineering and medical sciences combined can be said as a biotechnology, and this comes under biotechnology. That's why it is here. Okay, mobile communication using the latest smartphones and notebook computers will get advanced using this nanotechnology. Nanomaterials are used for heart patients and even used as artificial blood cells. Nanomaterials and nanoelectronics will yield lighter, faster, and safer vehicle and more durable, reliable, and cost-effective roads, bridges, rail systems, etc. See, one more time, I'll be repeating you the amplification for biology and engineering. See, nanotechnology can provide new formulations of drugs, advanced drug delivery systems, automatically administering drugs, and capable of censoring the drug level is a main amplification for biology by biology by nanotechnology. See, nanotechnology will bring out medical diagnostic tools, diagnostic devices for physicians, and nanotechnology, the study on cell biology and pathology to characterize the chemicals and mechanical properties of the cells. See, artificial, inorganic, and organic nanoscale materials are developed and introduced into the cell to play roles in diagnostics. Nano-engineered gels are used to replace the lost tissues or to provide structures for the regeneration of natural tissues. See, detection of a specific chemicals or biological compounds within a mixture represents the basis for the operation of numerous devices like chemical sensors, biosensors, etc. See, nanotechnology will contribute directly to the advancements in agriculture in a number of ways. It is a number of ways, but I'm going to give you just three main way. Molecularly engineered biodegradable chemicals for nourishing plants and protecting against insects. The first way. Genetic improvements for animals and plants, and finally nano array based technology for DNA testing. Okay. And finally, amplification for engineering. Nano engineering is leading to better fuel cells and photovoltaics. Nano engineered catalysts can be used to extract oil or turn oil into fuels for cars. Replacement of carbon black in tires by nanometer scale particles of inorganic clay and polymers. Nanoengineering replaces the chemotherapy with an injection of specially prepared nanoparticles that kill cancer cells for the patients. Significant changes in lighting technology are expected in next 10 years using this nanotechnology. Mobile communication using the latest smart phones and notebook computers will get advanced using nanotechnology. Nanomaterials are used for heart patients and even used as an artificial blood cells. Okay, nanomaterials and nanoelectronics will yield lighter, faster, and safer vehicle and more durable, reliable, and cost-effective roads, bridges, rail systems, etc. in future. Let's hope for the best and advanced community and society. Okay. See, with this content, let me give a short recap about the today's session. See, nanoscience is a study of structures and materials on the scale of nanometers. Nanomaterials are newly developed material at the size of nanometer ranges of range from 1 to 100 micrometer. The materials used to form these nanostructures generally have bulk properties, and its properties gets modified when when its size gets reduced to the nano ranges. Okay, and in general, nanometer is 1 billionth of a meter. Okay, a single strand of DNA is of about 2.5 nanometer. Width of the red blood cell is approximately 7,000 nanometer. Thickness of a single human hair is about 50,000 nanometer to 100,000 nanometer. Water molecule is of about 0.3 nanometer plus. See, on seeing all those above points, all those above discussed points, we can come to know that nanoscale structures exist in nature before scientists study and found them in laboratories. Okay, most of the works done by scientists and engineers in nanomaterials ranges from 1 to 100 nanometer. Okay, nanostructures can be formed in both solids and liquids. Nanostructures can be made by reacting chemicals in liquids and gases to generate nanofibers, nanocrystals, quantum dots, and some other of nanomaterials, which is about 1 nanometer wide. Researchers were going on to build out three-dimensional structures, which is known as nano electromechanical systems. One day, this nano electromechanical systems will be used as a microscopic robot to carry out two small tasks for humans, like doing out surgery on a single cell, even a single cell. This NEMS can also act as a mechanical actuator which moves around the individual molecules. To magnetize something 10 times, we need magnifying glass. To magnify than that, we need a microscope. To magnify in a nanostructure, we need a powered microscope. Scientists and engineers from various disciplines uses nanoscience principles for advanced applications in energy, medicines, information storage, etc. Nanotechnology is a design, production, characterization, and application of structures, devices, and systems by controlling shape and size as at nanometer scale. Okay, in general, nanotechnology is the synthesis and application of ideas from science and engineering towards the understanding and production of novel materials and devices. Now, coming to the amplification, nanotechnology is a technology that converts various fields like science, engineering, medical science, etc. The use of nanoscale engineering for the benefit of development of various fields like engineering, science is known as amplification. The two new technologies which enabled the progress of nanoscience are scanning tunneling and scanning force microscopy. See, coming to amplification for physics, most of the nanoscale particles are extremely small, so that the gravitational force is negligible. Okay, wave particles duality of matter of objects have very small mass has pronounced effect. Similarly, nanoscale materials have wave behavior. Quantum confinement is a change of electronic and optical properties when the material is sampled into smaller size of about 10 nanometer or less. 2D quantum confinement leads to quantum wire, and 3D quantum confinement leads to quantum dots. Okay, quantization of energy. Energy is quantized in some systems. Some system can have only certain energies and not a continuum of energies. Quantum dots are the nanomaterials that display the effect of quantization of energy. Cooling chips can be replaced in place of chemicals used in coolant, which is in compressors of cars, refrigerators, air conditioners, etc. Photovoltaic, coming to photovoltaics, this going to bring out an inexpensive clean energy. Nanoparticle reinforced polymer, new class of material consists of traditional polymers reinforced by adding nanoscale particles called nanocomposites. Adding even a small amount of nanoparticle leads to drastic improvement of strength and stiffness of the polymer. This nanoparticles reinforced polymer gives out a lightweight material. Now, coming to amplification for chemistry, nanomaterial is formed by an atom or by the cluster of molecules. A cluster of molecule leads to an atom. Okay, they're classified into two main types. One is intramolecular bonding and intermolecular bonding. Intramolecular bonding is a process by chemical interaction, and intermolecular bonding is a process by physical interaction. Okay, nanoscale particles exhibit high equilibrium, vapor pressure, chemical potentials, and solubility when compared to bulk materials. Okay, new cathode nanomaterials for lithium batteries or the target for novel nanostructures. Construction of nanostructures is by chemical vapor deposition of benzene on copper in an ultra high vacuum chamber. Nanofluidics is a study of behavior, manipulation, and control of fluids that are confined to structure of nanometer dimensions. Now, coming to amplification for biology, nanotechnology can provide new formulations of drugs, advanced drug delivery system, administering drug delivery, etc. All these are the amplification for biology by nanotechnology. Medical diagnostic tools, diagnostic devices for physicians are also brought through the nanotechnology. Studies on cell biology and pathology to characterize the chemical and mechanical properties of the cell. See, artificial, inorganic, and organic nanoscale materials are developed and introduced into the cells to play a role in diagnostics. See, nanotechnology will contribute directly to advancement in agriculture in a number of ways, but we are going to discuss about three ways. One is molecularly engineered, biodegradable chemicals for nourishing plants and protecting against insects, genetic improvements for animals and plants, nanoarray based technology for DNA testing. Now, finally, coming to amplification for engineering, nanotechnology is leading to better fuel cell and photovoltaics. Nano-engineered catalysts can be used to extract oil or turn oil into fuels for cars. See, nanomaterials and nanoelectronics will yield a lighter, faster, and safer vehicle, and more durable, reliable, and cost-effective roads, bridges, rail systems, etc. Nanoengineering replaces chemotherapy with an injection of specially prepared nanoparticles that kills cancer cells for the patients. Significant changes in lighting technology are expected in next 10 years. Replacement of carbon black in tires by nanometer scale particles of inorganic clay and polymers. Mobile communication using the latest smartphones and notebook computers will get advanced using this nanotechnology. See, that's all about today's session. We have discussed about nanoscience, nanomaterials, nanoscale and technology, amplifications. In case of amplification, we have seen amplification for physics, amplification for chemistry, amplification for biology, and finally the amplification for engineering. Hope all have enjoyed today's session. Uh, uh, let me thank all the listeners of the session. Thank you.